In this video, we're going to be taking a look at permutations and combinations. This is our last set of videos looking at different counting techniques, so different ways to come up with total number of possible outcomes for a scenario. And permutations and combinations are one other good method for doing that. Now in the last video we looked at a tree diagram dealing with drawing marbles out of a bag, and we only drew two, and you saw how wide kind of the tree got when it grew, right? It grew from side to side and it kind of started expanding here, and you can see it gets pretty big. Now we only drew twice. You can imagine if this were 5 draws or 8 draws, not going to be so much fun to look at that tree growing from side to side. So then the question is, can we come up with a better method for calculating total number of possible outcomes rather than making just this giant tree that grows as we move from side to side? And permutations and combinations are both good ways to do that. And you use them in very different scenarios. So we want to take a look at when do we use which one and how do we do that. Let's start with permutations. When do we use permutations? Permutations tells us the number of ways we can arrange n distinct objects selecting them r at a time if order matters. Okay, so that's the key to when we use permutations, is if the order that the objects are selected in is important. And if order matters, we use permutations. Otherwise, as you can see in the next one that we'll talk about, we'll use combinations. Now, the notation for this looks kind of interesting. It's Pn, R. That just stands for permutations of n objects taken r at a time. And it's equal to n factorial divided by n minus r factorial. Another notation that you'll very commonly see here, and this is one notation that your calculator uses, and instead of Pn, r, you might see npr. This is actually the notation that I prefer. It's easier to remember because all you have to think of is National Public Radio, NPR. But this is the formula for calculating permutations. There's also a program in your calculator that will come up with permutations as well. I'll show you how to do that in another video. But here, if we're looking at these permutations and how we calculate them, you may not have seen this factorial before. If you had, for example, 3 factorial, what that represents, it's a shorthand way of saying 3 times 2 times 1. Okay, so 3 factorial is 6. 5 factorial would be 5 times 4 times 3 times 2 times 1. Okay, so we'd have what, 20, 60, 120. Okay, so it's just a shorthand way of writing that multiplication of this digit times all of the positive integers lower than that digit, stopping with 1. Okay. Now your calculator does have a factorial button. Or a factorial, not a button, but it's in a sub-menu. You can put in a factorial, and I'll show you how to do that. And then also in another video, I'll show you how to do this entire thing in a shortcut on the calculator. But let's talk about permutations and when we might use them. And how can we tell that it's permutations rather than combinations? Okay, how do we know that kind of stuff? So let's take a look at, let's see. Here's a lottery example. So we have a lottery, and in this lottery there are 10 finalists who submitted tickets on time. And from those 10 tickets, there's going to be 3 winners who are drawn. The first prize gets $1 million. Second prize gets $100,000. And third prize, whoops, you totally can't see this. I'm writing off the edge of the paper here. There we go. Third prize gets $10,000. Okay. And what we might want to know is how many different ways can the winners be drawn? And we're going to do this without replacement. Notice that we wouldn't replace the lotto because you wouldn't be able to win the 1 million and also the 10,000. Okay. So we would be doing this without replacement. How many different ways can we draw the winners? Okay, so the first thing that you have to ask yourself when you're deciding whether you want to use permutations or combinations is the order in which the individuals are drawn important? And in this case, I think you'll agree, it's going to matter a whole lot to you whether you get picked first, second, or third. If you get picked first, you get the million. If you get picked third, you get the 10,000. That's a big difference. Okay, so order here matters. And because order matters, that's when we use permutations. Okay, if the order didn't matter, we would be using combinations. So then we need to figure out, if we're looking back up here at our permutations, we're going to arrange n objects and we're going to select them r at a time. So we need to figure out in this problem what's our n and what's our r. So the n is the number of objects you're choosing from. And in this case, we had 10 finalists who submitted their entries on time. So that's the number of tickets that we have to choose from. We can pick from only those 10. How many things are we choosing? Well, we're choosing 3 grand prize winners. So our R is equal to 3. We are choosing 3 individuals from a group of 10, and order matters. Okay. So then if we're looking at this P, N, comma, R notation, we'd be looking at permutations of a group of 10 where we're choosing 3, N, comma, R. That's equal to, according to our formula up here, n factorial, so 10 factorial, divided by n minus r factorial, 10 minus 3 factorial. So what we're looking at is 10 factorial over 7 factorial. And certainly you could do this out longhand if you wanted to, but I'll show you how to put it into the calculator. So if here is your calculator screen, and let me actually see if I can zoom in on this for you, just so you can see it a bit better. And get our focus. Hold on just a second here. There we go. Okay, so press your math key. Well, actually, first put in the 10, because we're going to need to do the factorial. So type in, 10. Then press your math key, and then use the right arrow key to scroll over to the probability submenu, and then your option number 4 right here is your factorial. So you can either scroll down to it and press enter to select the factorial, or you can just press the number 4, and that'll get your factorial on the screen. Then we want to divide by 7 factorial. So we'll put in the, or sorry, not 7. Yeah, it was 7. Wasn't it? Yeah, 7. Okay. I want to divide by 7 factorial. So we'll put in the 7, press the math key again, all the way to the right to the probability submenu, select factorial. So now we have 10 factorial divided by 7 factorial, enter. And we find out there are 720 different ways that we can select the winners without replacement. Okay, so 720 different possible outcomes if we're talking about permutations. Now combinations are a little bit different. Okay, so we'll talk about combinations next. And then again in the next video, I'll show you the shortcut for doing permutations and combinations on your calculator. So combinations, so if we're going down here, combinations tells us the number of ways we can combine n objects taken r at a time if order is not important. Okay, that again is the key difference between permutations and combinations. If order matters, we want permutations. If order is not important, we want combinations. And the notation for combinations, we use a capital C, N comma R. Or again, you could do NCR. You'll see that sometimes. It's equivalent notation. This again tends to be my preference. Your book uses this one, but the calculator will use this one. And the formula here is n factorial divided by r factorial times n minus r factorial. So let's find an example where we're dealing with combinations rather than permutations. Let's see. Let's imagine that we're asked to pick we're going to pick some computer programs. We're purchasing a computer and a printer, and we're given a choice of 3 software packages from a group of 12. And we might want to know how many different groups of software packages could be selected. Okay, so I've got 12 software packages I can choose from. From those 12, I get to choose 3 to take home with me. And I want to know how many different groups can I pick. Now the key here again is whether or not order is important, because if order is important, I have to use permutations. If order is not important, I'm going to use combinations. And the key here is if I get to pick 3 software packages, it doesn't matter if I pick software program A first and then B and then C versus BCA versus CAB. All of these, I would be walking away with software package A, B, and C. The order that I pick them in doesn't matter. Okay, so since order does not matter, that's what tells us that we're using combinations. And so again, now we're going to use our formula and our factorial. So we're doing C, capital C for combinations. We have a group of 12 to choose from, and out of that 12 I am choosing 3. So that's my N and my R. According to our formula up here, that means I take N factorial, so 12 factorial, divided by R factorial, so 3 factorial, times 12 minus 3 factorial. So I'm looking at 12 factorial over 3 factorial times 12 minus 3 would be 9 factorial. And I'll want that denominator in its own set of parentheses when I'm doing this computation on the calculator. So this is what I'm going to put into the calculator here. Again, I'll take my calculator and put it under the screen and try and zoom in here for you, just so you can hopefully see this a little bit better. Ooh, there we go. Let's see if I can get that to focus in just a touch better. Whoops. Come on, focus. There we go. Okay, that's pretty good. All right, so we had in the numerator 12 factorial. So we'll type in 12, go to math, over to probability, select our factorial, divided by, then we had in parentheses for the denominator 3 factorial. So go again back to math, probability, factorial, times 9. Math, probability, factorial. Close out my parenthesis. And this tells me there are 220 different ways that I could do that. Okay, 220 different ways of selecting 3 pieces of software from a group of 12. And so if I zoom back out here, oops, too far. There we go. 220 ways of doing that. Okay, so that's my total number of possible outcomes. And that's how permutations and combinations work. Again, they're just another method for getting us total number of possible outcomes. Now I'm also going to go ahead and post a video that will show you the shortcut for doing the permutations and combinations calculations on your calculator. There is a separate program for both permutations and combinations, so you don't actually have to enter all of this manually. So take a look at that video as well.